I didn't get it up to almost 8:30 because I had a doctor's appointment after school in Lafayette, so I didn't get home till 5.
Oh, I did like
Oh, yeah.
So glad you're looking out for me, James.
It's easy for us.
I know there's no, like, hidden agenda there. It's just all concern for me. All right, get your heading on your notes. Today is the 13th. Shh. Yesterday we worked with radical equations. Today we're going to work with radical inequalities. But just like with the equations, we still want to isolate the radical on one side and do all the stuff we did yesterday. There's just an added step that we have to take into account. In order to be able to solve this inequality. Yes. I know. I don't know what the deal is today. There we go. Here we go. Remember, when we solve inequalities, we can usually graph our answer on a number line because it's not just a single solution, it's a set of solutions. All right? I'm not going to bring back interval notation and set notation and all that. But we did do that. So we need to make sure that we keep the values of the radicand positive. Okay, what is a radicand? It's whatever is under the radical. Whatever is under the radical, that's the radicand, okay? As long as our radical is an even radical, square root, fourth root, sixth root, 50th root, whatever, it's an even root. You have to do this step first. If it's not an even root, you can skip this step completely. And this is why. Can you take the square root of a negative number? No. So we want to identify, since our solution is not just going to be a single answer, it's going to be a set of numbers. We want to make sure that whatever is included in that set does not cause this radicand to be negative. Because if it does cause it to be negative, then this whole inequality is invalid. All right? So our first step when it's an even root is to make sure that this is not negative. So what we do, now look, notice, I'm not even concerned with this anymore. I want to find out what values of x will make that expression bigger than or equal to 0. Because I want that expression to stay positive or 0.
1.
Okay? Well, when we solve this inequality, we add 4 to both sides. Then we divide by 4. So, in order for this to be a viable inequality that has real numbers as its solutions, x must be bigger than or equal to 1. Okay? Now, I'm going to find out what is the actual solution to the entire inequality, and I've got to make sure that I cut it off at 1. All right? So now that we know this, we're going to start off by graphing that. X must be greater than or equal to 1 in order for this inequality to even exist. Now let's actually solve the inequality. Forget about the graph now and let's solve the inequality. All right, just like we did the equations yesterday, the first step is to isolate the radical. Well, what's not under the radical? 2. It's 2 plus. So how do you get rid of 2? You're going to subtract 2 from both sides. Okay? And so you have the square root of 4x minus 4 is less than or equal to 4. Then what? Square both sides. So you simply have 4x minus 4 is less than or equal to 16. All right, now we solve for x. 2 steps. What are they? Add 4, then divide by 4. So 4x is less than or equal to 20, or x is less than or equal to 5. All right, so my solution for this inequality is that x is less than or equal to 5. Okay, so I go back to my graph. But I said that if x exists anywhere over here, then that's not even a valid inequality because we have a negative number under a radical and that's not a real number. So when I graph those two things, I'm looking for where they overlap each other because that is the solution. Where do they overlap each other? From here to here. How do I write that answer? Well, x is located between 1 and 5. It's bigger than 1, smaller than 5. It includes 1, and it includes 5. That's not too bad, huh? I mean, it requires you to remember things and think.
Are we gonna ever have to do the ones where, like, for this, where they go like out like that?
No, because you want to satisfy both of them. If it goes out like this, it's no solution.
Oh, so
Because you can't satisfy this and this at the same time. Okay?
So we always have to.
They have to overlap. You have to look for where are they overlapping each other. Yes?
What was the first step?
The first step was making sure that this expression is greater than or equal to 0. So you take the expression under the radical and you set it greater than or equal to 0 and find out what x must be. Yes?
Can they both be doing positive? Like,
Yes.
okay.
They can both be, and we're going to see an example of
I
that.
have to put like the infinity sign, whatever.
No, you just put greater than or equal to. Okay? That's those set notation and set builder and all that. Yes?
But you don't do that if it's
An odd root. If it's an odd root, you skip that step completely. Okay. Now, you remember how we had to test our stuff yesterday?
Yes.
Okay, well, we need to test here also to make sure. If I'm saying that the numbers from 1 to 5 do solve the inequality, I need to check that, and I need to make sure that numbers not included in that solution set do not solve the inequality. So what I do is I choose something to the left of my solution set, which here would be x equals 0. I choose a number that's inside my solution set. I just chose 2. You could choose 1, 2, 3, 4, or 5. Because all of those numbers are included in your solution set. And then I choose a number that is outside my solution set to the right. And I'm going to plug that in for x and make sure this should not solve the inequality. This should solve the inequality, and this should not.
Then why do you have to do that?
Because I want to make sure that there are no, see, I'm saying nothing past 1 will solve this inequality. I need to test and make sure of that. Okay? All right, well here, if x is equal to 0, let's solve this. 4 times 0 is 0. 0 minus 4 is negative 4. Well, right now, what's the problem? Square root of a negative. There is no solution to that. Okay? Good. It's supposed to be that way. If x is 2, 4 times 2 is 8. 8 minus 4 is 4. 2 plus 2 is 4. Ugh. And 4 is less than 6. Okay, good. It's supposed to be. And if x is 6,